All right, today we need to find the area between curves when we're working sideways. And let's say that I had this example. We've got x equals 1 minus y squared. Our other function is x equals y plus 2. Y equals 1. Y equals negative 1. The first thing we have to do here is we have to figure out how to draw these on our graph so that we understand what's going on. So this function, the top one, all right, we want to think sideways parabola. And if you think of the way a parabola normally works, then this makes sense. Okay? When we do a regular sideways parabola, let me show you what we mean. If I had x equals y squared, it's going to look like this. Okay? So that, and if you think of that as each piece is part of a square root function, the top part and the bottom part, it makes sense. Okay? So this is x equals y squared. If I had x equals negative y squared, it would be like this. This is x equals negative y squared. Okay? So with that in mind, going back to our original graph, this is negative y squared plus 1. So it's been moved to the right 1. Now, this other one is just what we think it is. It's a plain old linear, all right, that looks like this. Okay? Y equals x minus 2. Let me draw that a little bit better. It does go through negative 2. So it's probably a little bit more like this, okay? And then we've got these two horizontal lines, 1 and negative 1. All right? So I've got a horizontal line here, y equals 1. And I've got a horizontal line here at y equals negative 1. Setup is critical on this problem because the actual integration piece is not real hard. The area that we're looking at is this area in here that we need to find. And once you see the picture, all you have to do is integrate the right function minus the left function. All right, so we are going to integrate the right function minus the left function. Instead of top minus bottom, it's right minus left. That's the only thing that changes. And so if we were going to set up the integral for this problem, this one is the right, and this one is the left. Okay? So I would just do the integral of y plus 2 minus the left function, put it in parentheses to be safe, dy. my limits of integration are here and here. So my limits of integration are negative 1 to 1. So your limits of integration are the bottom and top y values instead of the left and right x values. Okay? Once you get that set up, everything is the same. We integrate the same way. We do everything the same. We should be able to do this fairly easy from here. Let's work on the setup of another problem. All right? Because setup is really the most important thing here. Let's say that I had x equals y squared minus 4 and y equals 2 minus x. And that's all they told you. And you're supposed to find the area between them. Well, first, I have this sideways parabola, which is facing to the right and moved to the left 4. 1, 2, 3, 4. And then I have a regular old linear with a y-intercept of 2 and a negative slope, which I happen to know is right there. And so the region that we're going to find the area of is that. So in this case, when I do right minus left, this is right, and this is left. So my integral, in this case, would be 2 minus x minus the quantity, I'm sorry, not 2 minus x, we're doing this with respect to y. Give me a second there. We need to solve that thing for x. So we need to take this thing, this y equals 2 minus x, and put it in terms of y. So probably the easiest way is to add x x plus y equals 2, subtract y, x equals 2 minus y. So the right function is 2 minus y. The left function is y squared minus 4 dy. What are my limits of integration? Just like yesterday, it's the intersection points. And so to find the intersection points, we have to set the two functions equal to each other in terms of y. So I'm going to set this equal to that. And my limits of integration will be y values. So I would set y squared minus 4 equal to 2 minus y, which is a simple quadratic. All right. So when we get everything on one side, we have y squared plus y minus 6 equals 0, which factors into y plus 3, y minus 2. So my limits of integration would be negative 3 and 2. So the key thing is getting graphs set up correctly, and then remember that your limits of integration, okay, are y values. And remember that we're integrating right minus left when we do it with respect to y. And we'll stop there.